Hello, how are you? Okay. Today's video is of class 7. Sorry, class 8. 7 also can. And the topic is square roots and squares. All of you know what is square and square roots, right? So this one, just a brief discussion of squares and square roots. Okay. What is square? Very simple. If I say within 5 minutes only I can finish up this chapter. Square. Square means this is a square, right? Am I right? This is a square. What is the property of a square? The square, the sides are same. So what is the area of the square? Say suppose this is 5 centimeter and this is 5 centimeter. So what is the area? 5 into 5. That's all. Finished square. Always remember, whenever you will be asked to square something, that number into that number, and it is written as like this: 2. 5 to the power 2. I think all of you have done exponents or powers, so this is a part of the power. Square is whose power is 2, or whose index is 2, or whose exponent is 2. Say suppose if I say 10 square, that means 10 into 10. 5 square, 5 into 5, 9764 square is 9764 into 9764. Clear? Okay, but there are a lot of ifs and buts in this square. Don't get scared, very easy. Just observe, see. Let me write down some square numbers. What is the square of 1? 1, 2, 4, 3, 9, 4, 16, 5, 25, 6, 36, 7, 49, 8, 64, 9, 81. Right? Now, see, from here, what are the numbers? Like these are the squares, right? Sorry, squares. So these all are the squares. Can you tell me which square numbers? Okay, previous to that, let us know what are called perfectly squared numbers, or perfectly square, or perfect square. Perfect square are these numbers. Like suppose if I say 16, 16 means 4 into 4, that is 4 square. If I say 81, that is 9 into 9 is equals to 9 square. So these 16, these 81 are called perfect square or perfectly square. But suppose if I say 47, if I say 44, if I say 62, are they squares? No. They are not square numbers, perfectly square numbers, because you cannot multiply any number with that same number to get this 44. Now how will you know? Suppose if I say 6, 4, 3, 2. Tell me whether this is a perfect square or not. So what we should do? We should factorize 6, 4, 3, 2. If I factorize 2 3s are 6, 2 2s are 4, 2, 2, 2, 2, then 3, next nothing else. Now you see, here I can get 2, 1, 2, 3, 4, 5 into 3 into 67. This is not squaring up, right? Right? So this is not a perfectly square number. Is that clear? All of you understood? Okay. Now, in squares, there are some patterns. Pattern means whenever you will be getting the square, perfectly square numbers ending up with either 1, you see, that means this is 1 or 9. Clear? Like suppose if I say 72, what should be the ones digit of 72 square? Now what should you do? You should multiply 72 into 72, then find out what is the answer coming, then you will tell me? No. Very simple. What is the square of 2? 4. That means the number here, whatever it will be, I don't know, but the ones digit should be 4. Suppose if I say 439. 439. What should be the ones digit of the square of 439? Whatever be the number be, it should be the last digit 1. Why? 9 9 is 81. Understood? 10. 10 square is 100. Okay, this one I'll explain elaborately. 10 square, 100. 100 square, 20 square, 200 square, 100,000 square, 2,000 square. Okay. Very first time writing, right? How? I memorized all. No. Pattern. What is the pattern? Let's see. See, here 10 square 100 we know. So what's happening? Whenever you will be finding the numbers ending up with 0, very easy to find out the squares of those numbers. Very easy. How? First, what is the number 1? You write 1 square. 1 square means 1. Then 0. How many zeros are there? Only 1. If there is 1 0, it will be doubled. It will be 2 zeros. See, 100. Here 1. So 1 square means 1. How many zeros are there? 2. Double it. That means 4 0. See. Here is 2. 2 square is 4. How many 0? 1. Double it. 2 0. See. Here is 2. So 2 square is 4. How many zeros? 2. Double it. 1 2. Here is 1. 1 square 1. How many zeros? 3. Double it. 1 2 3. 1 2 3. Here how many? 2. 2 square is 4. 3 0. 1 2 3. 1 2 3. Square means write 2 times. Clear? Similarly, from here you can find any number of squares of digits or numbers ending up with 0. Suppose if I say 60 square, 900 square, 4000 square, 11 square. What it will be? First tell me. Quick, yes, I can hear you. Don't think that I cannot hear you. I can. Tell. Come around with me. 6 square, 36. How many 0? 1, double. 9 square, 81. 2 0, 1 2, 1 2. 4, 16, 3 0, 1 2 3, 1 2 3. 11 square, 121. 1 0, double it. Finished. Clear? Very hard. Very hard. No, not at all. Okay. What's all? What else? In the book, you will get some patterns. Pattern means this is not the rule, but by observation, we have seen that the numbers ending with 6, they are the squares of the numbers whose ones digit is either 4 or 6. Very easy, this one no need to memorize also. Suppose I told you that 36, clear, or 16. This is a perfect square number. Now the ones digit is 6. So whose last digit is 6? 36 means 6 square, 16 means 4 square. That means from here, I can, even if you say 16, it's 256. So this one we can say it's a rule, or rather it will be better if we say it's a pattern, that the numbers ending with 4 and 6, the numbers ending with 4 and 6, their squares are the numbers ending with 6. So if I say, write true or false, that 726 square is equals to 1, 2, 3, 4, 5, 7. Is this right? No. Why? Because here I can say no need to multiply 726 into 726. No. Just look at the pattern. 6 square is 36. That means the end will be coming 6. But here the end is 7, so it cannot be. Okay. Next. Like this, you will get a lot of patterns in your book. I'm not wasting the time to elaborate all the things. Okay. Let's go to the exercise. Let me see what is there in the exercise. Okay, one more thing. Pythagorean triplet. This is nothing. This is, let me take one example. Wait. Let me take one example. Where is Pythagorean triplet? Where is Pythagorean triplet? I can find in the book. Okay. Suppose 3, 4 and 5. Pythagoras theorem states that if you know about a right angle triangle, this is the base, this is the height, this is the hypotenuse, or you say this is the perpendicular. So base square plus perpendicular square is equals to hypotenuse square. So this number will be a Pythagorean triplet when 3 square plus 4 square should be equals to 5 square. Now let us see whether this is right or wrong. 3 square means 9, 4 square means 16, 9 plus 16 25. Yes, it is right. So I can say it's a Pythagorean triplet. Clear? Just a moment, let me find out one sum. Just give me 2 minutes. Where is Pythagorean triplet? Cannot find. Find the squares of the following numbers. Here we came to square roots. It should come before square roots. Okay, there I got one sum. Okay, so for Pythagorean triplet, you remember one thing, that is 2m, m square minus 1 and n square plus 1. What is the, let me copy the sum. Find the smallest number 8. Okay. Find the Pythagorean triplet whose smallest number is 8. So always remember this form or this formula. This is 2m, m square minus 1, m square plus 1. This is the Pythagorean triplet. Now we have to find out like these three numbers whose smallest number is 8. So let 2m is equals to 8. So if 2m is equals to 8, that means m is equals to 4. That means 2m is equals to 8. Then m square minus 1 is equals to 8 is 64 minus 1 is equals to 63, and m square plus 1, that means m square plus 1 is equal, m is equal to 4. That means 4 4s are 16 minus 1 is equals to 15, and m square plus 1 is equals to 17. That means 8, 15 and 17 are in Pythagorean triplet. Let me find some tricky sum for you. Wait. Okay, number is 12. Same question. Here only this is 12. Now see, this is 12. So same thing, let 2m is equals to 12. See the tricks here. Therefore m is equals to 6. Therefore m square minus 1 is 36 minus 1, 35, and m square plus 1 is 36 plus 1, 37. Clear? So here the number is 12, 35 and 37. Okay? Clear? Okay. So this is all about square. Now we will be going to square roots. What is square root? Just the reverse of square. Just the reverse of square. Before that, again let me remind you, go through the patterns that has been given in your book. Okay? Okay. Now square root. Just now I said say 256. This one means 16 square. So 16 square is 256, and the square root of 256 is equals to 16. How will I write it? We should put this sign. This is the sign of square root. So square root of 256 is equals to 16. Just the reverse. 11 square is 121 and 121 square is 11. 12 square is 144. Square root of 144 is 12. 13 square is 169 and square root of 169 is 13. 14 square is 196. Square root of 196 is 14. 15 square is 225. Square root of 225 is 15. If possible, please learn by heart or remember the squares of the numbers from 1 to 20. Okay? Okay. Now, why I am telling you to remember? It will be easier for you to do the sums. If you can do the sums, you can do the calculations very easily. But it's not possible for us to remember all the natural numbers, right? Say suppose 746. It's not possible. So we have to know the method how to find out. Suppose I say 1, 2, 3, 4. Find the square root of this number or find whether it is a perfect square or not. How? Same thing I told you, factorization. So 2, 6 and 12, 2 was a 2, 2, 7 is a 14. Then anything? Nothing. 13. No. Let me take some other number. Let me take the help of the book. Find the square. Where is the square root exercise? Okay, now I got it. 5929, 5929, 5929, 5929. Three, is it going? No. 3 not going. So what it should be going? 5 and 14, 16, 25, 5 and 7, 11. 11 finds the 55, 42. 11 3 is the 33, 99. 11 9 is the 99. Now see, for this thing you should be very expert in rules of divisibility. You remember the rules of divisibility? If not, please go back to the junior classes. No need to go and do the classes of class 4 and 5 and 6. Just go through the books and learn the rules of divisibility. Again 11, 4 is a 44, 9. Then 7, 7 is a 49. That means 5 to 5, 9 to 9, I can write as 11 into 11 into 7 into 7. Now, square root of 5929. See here, for every pair I will take one number. Here is one pair of 11, means there are 2 11s, I will be taking only 11. Here are 2 7s, I will be taking only 1 7. So the square root of 5929 is 77. Is this clear? Are you sure? This method is called prime factorization method. Why? What I am doing here? I am factorizing and these are all prime numbers. That's why it is called prime factorization method. Clear? Now, this square root can be found in one more way. That is called division method. Division method. division method. 5929, right? The number was. How should we do this division method? My dear students, please practice this method more and more. Okay? This is very more easier and more sophisticated, and you can do the sums more quickly if you can get yourself expert in this division method. So rule number 1, you should pair up the digits from the end. Means here is the last number, from here take up here, then take up here. Suppose it was 59297 last. Okay, so this cannot be formed up here because only one number, let it be like this. So for this number, division method. So first is 59. Think whose square can be 59? 8 8s are 64. That means below 8, 7 7s are 49. Okay, 7 7s are 49. Clear? Minus 10. Then rule of division, bring the next number. Here next number means next pair. So bring this pair. Next what you should do, here is 7, double it up. Double, not 7, double. 7 2s are 14. Always double. Now here you should put such a number. By that number you should multiply this whole number. Like for an example, I put here 3. So I should multiply 143 by 3. If I put here 5, I should multiply the total 145 by 5. Understood? This is the rule. Now we have to think and put such a number here. By that number we should multiply this whole number and get this. How will you get? Okay. If you cannot think anything, there is one option. Here is 14, put 1 here, multiply 1, 141, cannot. Put 2, multiply by 2, 284, cannot. So 143, multiply by 3, cannot. 144, multiply by 4, C, cannot. 145, multiply by 5, cannot. So this is one method. From 1 to 9, keep on multiplying and waste your time. And if you want to listen to me, if you want to follow me, how I do, see 9. So whose number should be the last digit? 9. Either it should be 3 or it should be 7, because you see 1 square 1, 2 square 4, 3 square 9, 4 square 16, 5 square 25, 6 square 36, 7 square 49, 8 square 64, 9 square 81, 10 square 100. Now here I got 9. That means here you see, here I got 1 9 and here I got 1 9. That means either this should be 3 or it should be 7. Understood? So if I put it 3 14s are 52. Sorry, 42. But here it is 102. Cannot. So let me put 7. Multiply by 7. 7 7s are 49. 4 7 4s are 28 and 4 32. 3 7 1 are 7 and 3 10. Now this 7 I should again write here, and the answer should be 5929 is 77. Yes, my dear students, is it very hard? Yes, sorry. What should I say? You know, sometimes I get out of my words. I can't express. Okay. Yeah, I remember. Primarily means for the first 1 or 2 days or for the first 1 or 2 sums, you will get it very difficult. But once you will get habituated, you will see mentally you can do. Let's find the square root of this. First, let me do it in time factorization method. So 2 8s are 16, 2. 2 4s are 8, 1. Now 3. 14, 7. Now. That means 1764 is equals to C. 2 into 2, 3 into 3, 7 into 7. What did I say? Square root of 1764 is take 1 from the pair. Take 1 from the pair. Take 1 only from the pair. Equals to 2 3s are 6 7s are 42. Clear? Okay. Now let me do it in the division method. 1764. Rule number 1, pair from the end. 17. Whose square is 17? 4 4s are 16. 1. Bring down the next number means next pair. Double it up. Now here is 4. So whose square will be ending with 4? Either 2 or 8. 2 2s are 4. 8 8s are 64. Now if I put 8 here, 8 8s are 64. But here is only 16. So here should be 2. So multiply by 2. 2 2s are 4. 2 8s are 16. These two put it here again. Therefore, square root of 1764 is, my handwriting is too bad. Please consider it. Sorry for the interruption. A phone call came. Not so urgent phone call, but then too, it was a phone call. Okay. What else? Just now what number did I do? 1764. Now suppose I put a decimal here. Now what should I do? Same thing. Pair from the end. But remember one thing here. Here the pairing up will be the decimal this side and form like this. Like suppose 1 5 3 6 4 9. Here is the decimal. So when you will be pairing, see, look this one carefully. When you will be pairing, so decimal here, this side like this side like this. Clear? Understood? Let me do with an example. Where I cannot get any example? Decimal where? Where is decimal? I can't find it. 1764 only one is there. What else? Okay, let's say 5776. 5776. Okay. Now let me put the decimal here. So this side. Now 57. 8 8s are 64. 7 7s are 49. Then here 9 and 8, 17, 1 then 7, 6. 7 2s are 14. So here, what should I put? 4. 4 4s are 16, 1. 4 4s are 16, 1. 4 is 1, 17, 1, 4 4 1, 5. It's coming 576. That means 300, right? So this 4 you should put here. And okay, here was 1 point decimal, so put the decimal. Have I done it? Okay, 7 7s are 49, 8 8 is 64. So 7, 49, 9 and 8, 17, 1 are 4, 5. 7 6 decimal, 7 2s are 14. So 4 4s are 16, 1. Okay, now for decimal, always 2 zeros will be coming because it's all pairing up. Now double of 74 is 148. Understood? Now 148. I think I have copied the sum wrong. Where the sum got? I cannot get it now. Now I see some other sum because it's a terminating decimal. Here it's not coming. Okay, let me do all this thing. 31.36. 31.36. 31.36. Okay, now 5 5s are 25. 6 decimal 36. 5 5s are 25. Now 6. That means it can be 4 or it can be 8. No, not 8. It can be 4, it can be 6. So if I put 4, it's not going. 2, 4. It's not going. Oh, sorry, it will be 10. Why 25? 5 2s are 10. So if I put 4, 4 4s are 16. So let me put 6. If I put 6, 6 6s are 36, 6 1s are 6. Okay, now see. So square root of 31.36 is 5.6. Clear? Understood? Okay. Now, suppose what was this sum? 13.36. 31.36. Suppose this one I want to do in factorization method. This one I can write 3136 by 100. Now square root of this one you find out the factorization, and 100 means 10. So whatever it will be coming, you just put a point. Understood? So by factorization also you can do. I think nothing else is there in squares and square roots. Okay, so please keep on practicing the exercises, and if any problem you face or any sums are there you can't do, just put it in the comment section. 100% sure I will get back to you. Okay, till then, bye bye.